Welcome everyone. In this session, we are going to create object detection model with YOLOX. We are going to start from data collection and create a label and training, and we are in friends. We have collected data from some demo videos. So in this video, they are creating a fire and showing how it is impacting. So we are capturing each frame, and we are saving as an image file. So this is one of the image file. So we are going to label them with using label me. So we open the label me, and so this is the folder, and we are going to select a rectangle, and we are create a bounding box. This is for fire, and this is for smoke. We'll save this as a JSON file. So now we can see one JSON file has been created. So like that, we have created JSON file for each image. Then we are going to create a Cocoa format. So we download the code from label me to Cocoa from the GitHub page. So we have to mention which folder has the image and JSON file, and this is the output where we want to store the Cocoa JSON annotation file. So we have mentioned this file, and we are going to execute. Okay, now it is created Cocoa format. So this is the annotation file which has image, categories, annotations. We just need only image files. So like that, it will create a training and validation path. So we'll see uh, the data which we are going to use. So this is the annotation. So this is for training, and this is for validation, and this is the image file for training. So these are the image file we are going to use for training, and these are the image file we are going to use for validation. We have uploaded the data into Google Drive, and we are going to use Colab for the training, and we selected runtime as GPU. So we already mounted into G Drive, so we can see. So this is the data we are going to use it for training. So first step, we need to download the YOLOX code from GitHub. Then we'll execute this command to install all the dependency packages. Dependency has been installed. It took some time. Then we are going to install Apex. So this has some utility functions for next precision, and some for distributed training. So we'll also install that. We'll downloading the code from GitHub, and we'll install that. So then we are going to use YOLOX. Yes. So we are going to download pre-trained model of YOLOX. Yes. So this one we are moving data from Google Drive to YOLOX datasets. So this data we moved from Google Drive. So then we are going to start the training. So we are going to YOLOX folder. Before start the training, we need to make some changes. Um, in Coco classes, it has some 80 class, but we are going to use only fire and smoke. We'll remove remaining classes. Then we are going to use um, this Python file, which has all the configuration for training. So instead of number of classes it shows 71, but we are going to use only 2, and we can change epoch and other details. So we can change the configuration. Then so this change is done. So we are going to use we are going to start the training. So it's a training.py. Python file will start the training, and this is the configuration we are going to use, and we give the batch file and expression, and this is a pre-trained model. So we can start the execution. So for now I'm going to use only one epoch for this training, since we already trained. In this GitHub, we can see some of the configuration we need to use for improving the accuracy. So they have some tips for best training results. So we can use these details inside this configuration file, and we can start the training. Okay, so the epoch has been completed. So we can see the models inside this. So YOLOX output folder. We have a model with 100 epoch, and we are going to use this for our inference. So we'll mention the path, and we are going to use this file for our inference. So it's storing the result in this path, YOLOX outputs. So we can see this is the fire and these are the smoke detected. We are moving the whole workspace into our Google Drive. Then we are going to download in our local. We have downloaded the code in our local, and we are going to add one line to view the output in the window. And for demo, we are going to execute this command for video. So we'll mention the our trained model path and the video we are going to use. And the rest of the things we are going to use as like the device we are going to use GPU. Let let us execute this command. So it started to detect the fire. We are going to add some more code to alert the user. So this is the code. If output has predicted any fire, um, it is going to send a message into Telegram. We have already configured the telebot, and we can find more resources how to configure this one. So for now, we are going to sending the uh, messages to the user, and we are storing the current frame in our local. Then we are sending this image to the user in the Telegram. We'll start the demo again. So it says fire has been detected, and it sends the images. Um, so we'll start the execution. So it alerts the user when the fire has been detected. So likewise, we can use for multiple use case if required any alert mechanism. Thank you.